As we had seen in the last class for data acquisition system, the main component is ADC. The ADC, one which converts your analog signal, like the signal from temperature sensor, humidity sensor, all these things into a digital signal. Digital signal, then we feed into microcontroller. So one of the popular ADC chip is ADC 804. Basically, it works with plus 5 volt and has a resolution of 8 bits. When I say 8 bits, it means if my voltage is from plus 5 to minus 5 volts, so every step, right? So the minimum voltage what I can represent is 1. So total 2 power 8 possibilities are there, like 0 to 2 power 8 numbers I can represent. So it starts from 0, then it goes with the step of 1. The first value, I mean, if the value in the digital is 1, then it is nothing but 0 plus 1 by 2 power 8. It's not 1 by 2 power 8, maximum voltage. Okay, so if it is like plus 5 to minus 5 volts, so every step, like total, we have 10 voltage range, right? So that resolution we say. Okay, so since like we have the 2 power 8 bit resolution, maximum voltage, like if it is like 0 to 5 volt plus 5 volt divided by 2 power 8 volt. This is the minimum voltage what I can represent in analog. So how long? For example, whenever I feed analog voltage to this A to D converter, immediately you will not get the digital data. It takes some time to convert that analog into digital. That conversion time, we call that conversion time is varies depending on what clock you apply. For analog to digital conversion, you have to apply a clock for conversion. So, but maximum speed at which ADC can operate is like 110 microseconds. This is the highest speed with which it can convert. So I'll show you the image of ADC pin diagram. You can see here we have input voltage V in minus. So basically here the reference voltage, right, plus 5 volt, and you can see a pot. So you can adjust this V in. So this is the input basically. I mean, just to see those, instead of pot, here some sensors will be connected. So this voltage I am converting into digital value, and I am feeding the clock values also here. So you can see here one RC oscillator is there, so which generates the clock, and the digital values, it is coming from D0 to D7, 8-bit digital value. You can get it from this form. So the input is these two things. So the reference voltage, we feed it here at the 9 pin. So as soon as you ground it, right, what happens? It stops, and like whenever it is open, okay, so if you see here, write and interrupt is active low. As soon as you press this, so your operation will start. It is the basic functionality of this and the frequency with which it operates is f equals to 1 by 1.1 RC. Okay, that is the clock frequency what it generates. So in order to get the operation of this, right? So I'll just give you the timing diagram. So that signal we have to generate in the ADC from the 8051. So if you see here, the chip select pin, first we have to make it low. So you can see here, right? So the chip select value that has to go low, and write should start high, rising it. So also your interrupt should go low. So then RD bar is the output, right? So actually what happens after your conversion time? So from here to here, right? The conversion time. So as soon as you make these two conditions, CS you made it low and write you made it high. So then your data out will come after conversion time. Okay. So let's take one small programming example. Before that programming example, let me just show you how this interface is connected. Okay. So if you see this particular interface, right, uh, the data is connected to the port 1, P0 to P7 of port 1, that is connected data. P2.6 write bar we connected. P2.5 read bar we have connected. P2.7 we have connected interrupt. And if you see, yeah, rest of the things are grounded. And input we are feeding. So this is a sensor for us. So I mean they have given one pot just to show the variation in voltage. Okay. So let's see the program. I'll paste that program and we will see line by line. So first line is basically it explains we are using 8051 header file. Okay. Then if you see the second line, I mean, first we need to understand this, where we have connected read bar, fifth pin of port 2. You can see read is connected to fifth pin of port 2, P2 XOR 5. So fifth pin of port 2. Then where write is connected, sixth pin of port 2. Interrupt is connected to seventh pin of port. And data I'm getting at the port 1. So you can see my data is connected to port 1. So I'll start the process here. So value is character. Character is nothing but how many bits? It is 8 bits. Our data is also 8 bits. That's where like I have defined value as a character. Initially, my data, it is defined as 0FF. So interrupt, I'll make it high. Read, I'll make it high. Write, I'll make it. So in order to read, right? So I have to make this as 0. Okay. Then high. I mean, if you see the diagram, we had seen one this diagram, right? So we have to make from low to high in order to start the conversion. So for that purpose, what I am making from low to high, I am making, right? Then while interrupt equals to 1, I mean, if I get the interrupt, that means, so this interrupt will become high once the data conversion is ready. Then I will make read 0. That means I am reading. I assign the value to my data. It means I am getting the data. Okay. Then I will make read 1. Okay. So the basic step is first I have to make write from 0 to high. That is the first step. So then I have to wait for this interrupt. So if this interrupt becomes high, this INTR becomes high, then I have to read value equals to my data. My data, I have defined this my data as what? Here, T1, right? I have defined my data as T1. So it will read the value of T1. So far, like we had seen interfacing the ADC. Now we will see interfacing the DAC. So if you are getting the analog data, if you are feeding the analog data to ADC, we will get the digital data. Now it is reverse. If I feed the digital data, I should get the analog data. So this digital data I will connect to microcontroller. So this application especially used for your motor drivers, right? Or if you want to control the brightness of LED, such application we usually use reverse operation, we convert. Or if you want to connect to a speaker, right? So then we need analog data. So we will be seeing DAC 0808, okay, or 808. So let's see the block diagram of it, how it is interfaced to 8051. you see here, I have connected. So here there is no clock and all of that. So directly, if I send the digital data to this DAC, it is going to convert. So parallel 8-bit data, where I have connected to port 1. So here it is simple. And basically what it does is, it's a weighted sum. Okay, so you will have V reference, and each bit, here 8-bit, right? So like whatever the value you have, right? So it is like that bit into 1 by 2. It starts from 1 by 2. Like for example, D7 by 2 plus D6 by 4 plus D5 by 8 plus D4 by 16 plus D3 by 32 plus D2 by 64, so on. D1 by 128 and D0 by 256. So any bit is high. For example, if I send 10000, it means actually 0.5 voltage into V reference. If my V reference is 5 volt, then you're going to get 2.5 volt as the output. So this kind of conversion basically works here. Let's see one sample program. So here it is actually a waveform generator using 8051. So actually, if you see my channel, right, in that you have another video where I have shown the trick for generating. That is a microcontroller is LPC2148, but logic remains same. You can check that also. Here, like they have given only a sinusoidal wave generation. Same way you can generate triangular wave, cosine wave, or sawtooth wave. That I have uploaded. You can just check that. Go and check that. So here, let's see here just one logic is there which shows how to generate a sinusoidal wave. Okay. Not getting off. So if you see this code, so basically we have to connect that data to send that data to port 1. And as I said, if I send like 10000, that is actually 128. That means 0.5 volts, right? So here they have calculated same voltage level and binary value for various value of sinusoidal wave, sine table. So if you pass these values, right, it is going to generate one sinusoidal cycle. Okay. So it is like one voltage samples they have stored. 12 such values they have stored. So in while one, so in the for loop, we will just read one value. It starts from 128 because see, we cannot have negative value, right? It should start from half of the maximum value, that is 0.5 volts, 2.5 volts. Then it has to go to maximum, that is 255, you can see. Then it comes back to 128 again, you can see this one, right? 128. And then it goes to 0. And again, it comes back to somewhere here, right? This way they generate sinusoidal wave, but it is not plus to minus. We have a bias of 2.5 volts. That is 0 to 5 volt sinusoidal wave they generate. Okay. So index they keep incrementing till 12, and then they repeat. I mean, from here onwards, again this will repeat. If you check it in oscilloscope output of DAC, you're going to see the sinusoidal wave. Okay. Next is stepper motor. So if you see here, in port 1, first 4 bit is connected to motor driver. So what we have to do, so it is like 4 magnets, okay? So it is like stepper motor will be having 4 magnets. So what you have to do, whenever you energize particular coil, right? So this will become north south, and internally rotor also will have polarity, south and north. So whenever you polarize this, right? So this is going to rotate this way. And now when you make again one more polarized, like north south, so this will actually move this way. And again, step by step, right? It keeps moving. So there are like various mode. I mean, if you want to have strong torque, so opposite end, right? So this end you have to make north south again. Here you have to make south north. So that what will happen? Sudden strong torque you will get it, right? So basically, stepper motor is like straightforward driving of like various values here. 0, 1, 2, 3. It is like actually we are energizing 1, 0. So if you go in the sequential order in the clockwise direction, the rotor also will rotate in the clockwise direction. If you change the direction of assigning the values, right? So then that rotation also will happen in the reverse order. Okay. So number of steps per revolution, usually see total revolution we have 360 degrees. So whenever you buy a stepper motor, they will tell you how much step they are going to give. So if they say step angle is like 60 degrees, okay, step angle is 60 degrees. Okay, if they say that like total number of steps is available like some 200, one 180, then 2 degrees is the step angle. Okay, so number of steps per revolution is actually, so step per second. Sometimes they will ask you to calculate step per second. Then that is nothing but rotation per minute into steps per revolution whole divided by 60. This will give you steps per second. Okay. As I said, there are like two modes. One is strong torque with the strong torque. Another is actually with a two phase. Okay. So like if you want to have with the strong torque or two phase, so two angles, like two magnets you have to energize in one shot. So if you see here, so whenever you send something like, so opposite coils like this and this, okay, you have to make one, rest of the things are zero, right? So here if you go in the order 1, 0, 1, so 1, 0, 0, 1. That's it. So next two values AB 1, 1, 0, 0, then 0, 1, 1, 0, 0, 0, 1, 1. So this will give you clockwise direction. So if you go in this sequence, your motor will start turning in the anti-clockwise direction. Same way, we have another method, that is half step method. Okay, or like one phase method also we can use. So in one phase method, what we do, only one value we keep shifting, that is a shift register. So if you see this side, so one value we keep shifting. No, this is again two phase. One phase one is, this is one phase. So you can see I have one, I'll energize one, then I'll energize B, C, T. If I reverse energize in the reverse way, then it will go for the anti-clockwise rotation. Let's see one small program. So if you see here, port 1 we are using, and we are sending hexa 66, but actually we use only 4 bits. 6 is nothing but it is 0, 1, 1, 0, right? Then we make it like 3, 0, 0, 1, 1. Then we made it 9, that is 1, 0, 0, 1. Then C, 1, 1, 0, 0. So this will create a clockwise direction, right? Clockwise direction with a step of 200 milliseconds, right? So if you want to have anti-clockwise direction, then you have to write another function where what you will be doing, from CC you will go to 99, then 33, then 66. This will create a anti-clockwise direction. Okay, very simple. Okay. Same way I have another program. If switch is like pressed, then rotate clockwise. If switch is not pressed, then rotate anti-clockwise. That kind of program, changing the direction. This will be especially used in robotics applications and all. So we have to check the switch status, and based on that, you have to rotate clockwise or anti-clockwise. So you can see here, we are checking the switch 1 status. Switch 1 is connected to port 2, 7th pin. 7th pin. If switch is pressed, then we go in the clockwise direction, CC. Then if switch is not pressed, we start from CC, you can see here. We start from 6, 6. Then see, from here we go this way, CC 9933. That is anti-clockwise direction. Okay. So you have in the 5th unit, there is like some ARM related stuff, right? So there are some already recorded sessions on that. So I'll share you that. Okay. So you can like, please, meanwhile, you can watch that as well. Like, so you, in your notes, like it is like very brief things are there, but I have covered in detail in some of the videos. I'll share those videos. Please watch that. Okay.
Yes, sir. Sure.
Yeah. I mean, like it's very brief in your videos. Like there, I have explained it neatly. I mean, from the very fundamental aspect. I'll share those links. Then in the next class, we will try to cover keypad, keypad interface. Okay, I think that's it. Keyboard interface. Yeah. So what is actually unit 1 and unit 2? You haven't shared me those notes, right? You can share me those as you mentioned that like you had not got last time. So maybe if you have that, like you can.
Yeah, sir. I guess they haven't sent it yet.
Okay.
Yeah. When once I get it, I'll send you.
Sure, sure.
Yes.
Okay. Okay then. Thank you.
Thank you.